Hey guys, I'm Nick and welcome back to the new tutorial. Today we will talk about pyro, we'll talk about the simulating sort of a tire burnout smoke, and also we will check how to colorize our smoke with Redshift. Today's tutorial is heavily inspired by this Sebas Zuluaga work that you can see right now. Few really cool works here, especially this one with this helmet and motorcycle, and yeah, I like this one. Really great work. Also, we are trying something different today. Of course, I have already built this setup, but many of you requested that I do step-by-step tutorials rather than sort of a breakdowns. I still think that in a long term, in a long run, it's better to learn something not by following a step-by-step tutorial, and my breakdowns are encouraging you to actually play with the values of the nodes, try out different parameter combinations, but as a experiment, because also this will take me a bit longer to record, so it might be harder to actually push 4 tutorials each month. But let's try with this one. So let me know in the comments how you like this format. Is it better than my previous tutorials, or I should stick with what we had before? But yep, let's go and start creating this setup node by node. So of course, this setup consists of 2 parts: our tire and our smoke simulation. Also, we will need a camera, and also we will need some sort of an HDRI, so RS light dome. Yeah, I think these are the nodes we will be working with. Of course, yeah, we also need a material network, so net. Right, I think we can start with a tire, because this tire consists of 2 files. Let's just go here, press B, so we have our beautiful parameters here, and let's go into the resources folder, and I have 2 of these STL files which I've got from GrabCAD, GrabCAD community, GrabCAD library, I don't know how to properly call it, but we have this tire. I like the details here. I like the fact that we have Eagle GT here. We will apply motion blur, lots of motion blur, so chances are we won't see all the details, but somehow I really like this tire here. You can see that it's very big. We don't need that. Let's drop a match size and make it smaller. Let's connect match size here. Target size would be 5, 5, and 5. And to actually see how the mesh size works, we need to check this scale to fit, and boom, we don't see anything because we are too far out, and we can press H and we will get back to we will like center the viewport on our tire here. Then we need UVs, because we will be applying procedural textures, noises, and to prevent these noises of from like flowing on our tire as the tire spins, we need UVs, and we will be locking our noise on the UVs. So auto UVs goes here, labs auto UV. I like this one a lot. I mean, I hate unwrapping, so I prefer the algorithm to do everything. So you can see we are packing right now, packing all the UVs here, and you can probably see that we have incorrect normals. Yeah, not the best UVs, definitely not the best UVs, but it's okay for now. So let's drop a reverse to reverse everything. We have normals? No, we don't have normals, so we need to add normals. Boom, and now we have normals on our vertex. Then we can already drop a material, because this one will be our tire material, and I think we are done with this setup. So we can layout distribute nodes vertically. Would be great if we could just make it tighter a bit. Maybe line nodes vertically. Nope. Nope, nothing works. Space, nose, vertically, nope. All right, so just let's make a logical block of this. So let's call it tire setup. So we know here we did everything that we needed to do for our tire. Now we need our rim, I assume that's how it's called in English. So let's drop another file, and here let's go and grab our XXR something, pretty detailed model of the tire and rim. And here you can see that we have the tire, right? But I preferred that tire much better. So yeah, for now let's drop a mesh size, and then we will delete the tire and just leave the rim. Yeah, that same mesh size, target size 555, scale to fit is checked. Again, we lost it, so press H. Then we need to, you can see here that our rim is rotated, so we need to also rotate it. Let's drop a transform, connect it, and let's rotate it by 90. And what I want to do now is delete everything that is not the rim itself. So let's drop a group, and here we can select or click actually on this little triangle, and now just start double clicking on the parts that we want to keep. And here you can see that I have this part, but I also need this, and probably there is something that I'm missing right now. So for now I can hit enter, then I can check which parts we have forgotten to include, and we see that here we have this edge here, yeah, that we probably need. So we can also again click on this little triangle here and hold shift and double click on these parts that we want to include. And now we hit enter again, and we have, I think we have everything that we need. So now let's drop a delete, plug the group into the delete, select our group 1, delete non-selected, and boom, we have everything that we need actually. So after our delete, after our group and our delete, we wanna, I know we can drop the auto UV. So let's plug it here. Let's again wait as it packs everything, creates UVs for us. All right. Then what I want to do is probably we want to reverse it, right? Because yeah, I want this part to be reversed. So reverse. Okay. Do we have normals? No, we don't. So we want to add normals. Connect. Cool. Then I assume we can drop a material again and call it rim material. Now we want to merge these two. Let's again select this one, layout, align nodes vertically. Nope. We want to distribute nodes vertically, right? And then let's again make a logical block and call it rim setup. We are not done yet because I assume that we will need to add another transform node here. Let's just select the tire material and rim material and merge it all together. And yeah, of course we will need, because the rim sticks out of our tire, so we want to drop a transform here into our rim. And yeah, just slightly push it back. I assume in Z axis. Yeah, this looks good. Probably we will need to scale it down just a bit, like that. Yep. So now I think it looks good. Yeah, this all looks good to me. Yeah, this part sticking out, I don't know, should we? I think we can ignore it just for now. Yeah, and these parts are reversed. Do we actually need to reverse it? I don't think so. Maybe we should, but I just don't want to select it all right now, and I don't think that I actually did it for the setup that I have. And here, let's just drop a null, and yep. Oh, actually, we need to do one thing, which is another transform node after our merge. Let's call it spin. And for the rotation, we will need to add a control null, but that will be later. So out wheel, cool. And we can probably call it a wheel also here. Nice. I think we have everything that we need. Just our wheel needs to repack all the UVs. Nice. We have a wheel. Into our smoke, we can hide our wheel for now. And in our smoke, we can do a few things. So, of course, we need to bring our wheel. So object merge does exactly the thing that we need. So out wheel brings our wheel here. Then scatter some points that will emit our smoke. Nice. Yeah, we have everything that we need. Let's drop a few more points. So now, you know what? Because this wheel will be the same size as our emitter, but also I want it to be a collider, we can have some difficulties. Yeah, you know what? Let's go into the front viewport, okay? And here, let's create a tube. Just a tube. Of course, we will need to make it bigger, and we want to make it z-axis. So radius scale goes like that. 120 columns, and then let's make it just smaller, a bit smaller, so it's actually the size of our rim, of our wheel, like that. Oh, actually no, we wanna make it a bit smaller, like that, and then we wanna poly extrude it. Let's go and plug it, poly extrude here, and yeah, extrude it like this. Cool. So now we have some sort of our wheel. Yeah, we obviously want to make it a bit wider as our rim. Yeah, I think like this. And if we go back to the front viewport, we might, no, actually, I think the size, the radius is good. Yeah, let's go back to the perspective viewport. Yeah, we don't need the wheel for now, so let's just focus on poly extrude. And here we scatter a bunch of points, drop the scatterer, around 5,000, I think. Yeah, now we can add transform, and somewhere here, let's drop a null, call it controls. And here in our controls, we go here on this gear icon, edit parameter interface. In controls, I like to add all the parameters that will be used more than once in the setup. So here we go with a float, which will be rotation. Oh, actually, no, it should be reversed. So label is more like a human readable format, and the name should align with the naming guidelines of your variables in Houdini. So apply, accept, we have our rotation here, and now we keyframe that rotation from 0 to frame 210. It should be 300. Oh no, it should be 900. So it will do 3 complete spins. We don't want actually any ease in, ease out. So for this rotation, let's go into the animation editor. Let's highlight our controls now. Let's highlight our rotation here, and let's go into this graph view. And now we can Control A or Command A, basically. And also you can press H to view the start and the end of your graph, and you can see that we have our Bezier curve. We want to change it to linear. Yeah, we don't need any cube. So now we can go here into the transform, and yeah, this is the right axis, and we go into the controls again. We right click on rotation, then we select this copy parameter, and then here in the transform, we go into the z-axis rotation and right click there in the slot where you kind of input your values for rotation and click this paste relative references. So now you can see that we have at the frame 210, we have our scattered points rotated 900 degrees. And you can see that now we inherit the rotation value from our controls null. So after that, we can calculate the velocity of these points. The velocity is basically the rotation here. So we can drop the trail. Let's go here into the trail. Compute velocity is the thing that we need. And yeah, I think here everything is default. Now we have the V. So we have computed the velocity. We can click on this display point trails and you can see that we have the trails here. And if we go into the geometry spreadsheet, you can see that we have some velocity. Cool. Nice. Obviously, we won't be emitting smoke from all of these particles here. So what we have is the wheel that spins in that direction. So the flame or the smoke will be going here. Actually, it depends on what kind of orientation we are looking for, but yeah, in my example, it was going down here. So what we can do is drop a group. You should probably name it correctly, but I'll skip that part. And now we can drop the box and go here and select the group type to be points. Keep in bounding regions, yes. And we want a bounding object, which is our box that we connected here into this input. And for this box, so basically, if we imagine that we have a wall here, let's just quickly merge box and group and our box. Let's pretend that we switch to the front view. No, we wanna back, yeah, like that. No, but actually, you know what? Let's just switch to the cam 1 and check. Okay, so we will need to rotate the camera like this. Yeah, cool. And now let's go to the back viewport and let's pretend that we have a wall somewhere here. Let's center it down. And yeah, so basically the friction starts here. So we can emit the smoke, I assume somewhere here. It will be good. So this box, the group here, we want to target everything that we don't need in our simulation. So these points, want to make it wider. And yeah, I assume we don't need this. But also we don't need these particles, these points here. So what we can do is drop in the box here and merge these two like this. And then plug this merge into our output object. So now we can create another box, make it wider, make it bigger, like this, push it here, make it wider again. And yeah, I think this is good. Yeah, somewhere here. So these will be the points that we use as our smoke source. All right, now we want to delete everything that we have selected. All right, let's call this group like inactive points. And now let's delete our inactive points. Yep. So yeah, we basically work only with these points here. But also, I think that we don't actually need the poly extrude because, come on, we are not emitting the smoke from the side of the rim, right? So yeah, I assume we just need the edge of our wheel. And then we probably wanna make our tube a bit bigger. So let's go to the front view. We disable the poly extrude here, and for our tube we tackle this radius scale and yeah, make it smaller, adjust it, yeah, like this. I think this will work. So now what we should have, yeah, are only these points here. All right, cool. Now we can work with these and set up our pyro source. So pyro source. Oh no, not the solver. Pyro source goes here, right? In our pyro source, we can initialize smoke. And also, thing that we will need is this particle separation. Let's go into the controls and add particle separation because we will be using this quite a lot. So psep particle separation goes here. Apply, accept. Let's leave it at 0.1 for now. And exactly at this part, I paused the recording in OBS to go drink some water, but then I come back, start doing this setup and describing all my steps, and I forgot to actually kind of unpause the recording, so yeah, I have a few nodes created here. So yeah, the pyro source is the one that we have stopped on. Then, because I want my smoke to be more dense here, where we are actually like rubbing that tire, pretending to rub that tire on the surface, I create this attribute wrangle. I create the pt dense variable, and I map that to the X position of the point. And then I drop the color, set the color type to be ramp from attribute, and the attribute pt dense. So then I can remap the range, and you can see probably here, if I set the view to be back viewport, we are somewhere at minus 2.5, I assume, here. It goes from the minus 2.5 to the minus 0.7 or something, and you can see that here, if I go back to the perspective viewport, you can see that here the value is 1, the value is kind of white, and here as we go closer to 0, the value goes black. Now what I want to do is bind that to the density, bind the color value, not the pt dense or whatever I created there. And this is how we will have the much denser smoke coming from that area where the tire is rubbing the ground, and here it won't be that dense. After that, of course, volume rasterize attributes, density, temperature, and V. And here in the voxel size, I have select this paste expressions, paste relative references here. So I have my psep, this variable from the controls, I have that in the volume rasterize attributes. Let's create this .NET again because it's crucial. I want to show you how it's done. So yeah, let's get ourselves a bit of space. We are not using Pyro Solver because the Pyro Solver has a bit limited collision options and bounce options. I will need to separate colliders here, and that's why we're not using Pyro Solver, we are using the DOP network. Let's connect our volume rasterize attributes to the first input of the DOPNet, and let's dive inside. So we want a Pyro Solver, but sparse Pyro Solver. We want a smoke object, but also sparse. Then we want to connect the smoke object to the first input of the Pyro Solver, and then we also need a volume source, which goes into the third input, which is sourcing. All right, cool. I don't think that for now we need anything more than that, just to make sure everything works. Volume source input should be first context geometry, and here to actually get all of our fields, we want to select something for now. Let's select the sink for now, and then change it to our source smoke. And then you can see that we have all of our fields, and we want to check this enlarge fields to contain sources. Then we go to the smoke object spurs. Voxel size, we also want to paste relative references here, and yeah, I think everything. Oh yeah, and here in the guides, in the multi-field, density field should be density, and diffuse field also density. Oh no, density. Yes, and now if I play, yep, we have our smoke. We have the buoyancy. Of course, buoyancy is breaking everything right now. So buoyancy scale in the Pyro Solver sparse should be set to 0. Gravity also 0 for now. because gravity is 0 for now, because I want to show you that if we play it right now, you can see that we are inheriting that velocity that we set with the trail SOP, and you can see how that smoke is coming out of our kind of rim, out of our wheel. So we will need to play with the volume source. Nope, we actually need to go into the pyro solver. Then in the shape, I wanna add turbulence, just a bit of turbulence. Yeah, much better. And here also, so the dissipation, the lower the value of dissipation, the longer the smoke will be visible in that smoke volume. So I was setting the dissipation to be 0.001 or something, just because I wanted our collider to fill up with the smoke. And that's basically it for the very, very basic smoke simulation. Now we will need to set up our colliders. So what I did here is I've already set the camera and I already have my smoke here. But yeah, and we can probably visualize it. Oh yeah, of course, it won't be visible just with this DOPNet. We need to drop a DOP import fields. And with these fields, we can choose the smoke preset. And our DOP network here, DOP network, we can just drag it here. And DOP node should be not in our wheel, it should be in our DOPNet here, the pyro solver sparse. Yay, cool, now it works. And yep, works pretty good. So now if we also need to add the spin, right, to our wheel. So let's go back to our smoke, let's go back to our controls, rotation, copy parameter. Let's go back to our wheel, and here in the spin, let's paste relative references. So if we, oh yeah, that's 0 here, which we don't need. Yay, cool, it works, awesome. Now we can direct our smoke a little bit better than it is right now. So what I want to do is create a few gliders. One of them will be static, which also will be kind of like a boundary for our smoke, and I want our smoke to actually kind of bounce off of the walls of the colliders. So let's create a box. Let's create a box and make it pretty big, I would say. So size something like this. Wanna center it in the frame, at least roughly. Then yeah, make it also high enough, like this, something like this. Yep. And also wanna make that box pretty wide, like this. Now I wanna make another box, drop a transform here, and I wanna make it bigger, like this. Just scale it up. Cool. Now want to drop another transform for this smaller box here, and I want to boolean here, drop 2 boxes, and want to get this smaller box to protrude a bit in the Z axis. Cool. Now the only thing I need is to actually, yeah, switch the sides. Okay, so what else we need is probably to make it deeper, and yeah, I think we have everything that we need. If I drop the object merge, yeah, I think we're good. I think we are good with this one. Also, what I wanna do here is add the border for the pyro, but we will do it a bit later. For this one, I wanna drop a VDB from polygons, because we will be using volume collisions, which works better with the pyro simulations. So VDB from polygons looks great. Let's drop a null out box collider. And now we also need to create a collider for our wheel. So how can we do it? We have our out wheel, which spins. So we definitely can create velocity trails. Compute velocity trail, we have the V on the points. Let's just go to the geometry spreadsheet and see, yeah, we have the velocity. Then what we need is to add VDB from polygons, because again, we will be using this as a collision source in our pyro. Voxel size should be something that we actually can work with. 0.03, 0.02 maybe. VDB reshape SDF will also do the job and will make our VDB much better looking. Yeah, much better. So for this one, let's drop a null, another null, and make it out tire collider. The only thing that we forgot to do, you can see that we have the surface here in the VDB from polygons. So we need to pass the velocity into our VDB. So here you can see surface attributes. Let's add one attribute and it should be point V. Vector type should be set to displacement velocity acceleration. And yeah, that's basically it. Now we have our velocity in our volume, in our VDB. So now we can implement these two into our .NET as colliders. So for now you can see that we have infinite box for our smoke. We can drop just the static object. Let's drop a merge here also and drop these two into the merge. And now we can add our box collider here. Actually set the collisions to use volume collisions, volume sample, uniform divisions, no, division method by size, and proxy volume. We have our out box collider, and we actually even don't need it in the sub pass. I think so, at least I think so. Or maybe, yeah, maybe we need it. Let's check what we have now. Cool. We have some collisions and we have some smoke that comes out of our wall, of our box. We can fix it with the smoke object sparse, and we wanna select that we add a boundary condition and the z-axis, I assume. So it should be closed below 5, I think. No, closed below 0. Oh, closed below -5, I assume. Yeah, because if we look down, yeah, it should be closed below -35, I think. Somewhere there. Let's check. Nope. Oh, yeah, -3.5, of course, not 35. And now what we have is, it should not come out, but somehow, oh, I think, yeah, we need -3.2, something -3.2. And now if we play it and see, yeah, now you can see that it does not come out of the box. But now we should somehow introduce our collider. And by saying collider, I mean our tire, our wheel, and actually it wasn't an easy task, because this new pyro source, like sparse pyro solver, actually is different from the one that we had. But this video from HoudiniSimon channel actually talks about this issue, where we need to add the collision source to the last input, which is absolutely not intuitive to me. So yeah, credits to HoudiniSimon, and thanks a lot for helping me out with this setup. So yeah, volume source again goes into the forces. And why? But yeah, anyhow, into the forces, subpass out tire collider, right? And this should have the collision preset here. You can see that source volume and target field are both collision, but here in our smoke we created the VDB that has surface and V as velocity field. Anyhow, we can go back into our DOP network and change the source volume to the surface. And to see that collision, we should go into the visualization in the smoke object and check that we want to see a collision here. Let's check if it actually works. So we kind of have collision, right? But there was one little thing that I was missing, and I found that in that HoudiniSimon's video. Here in the pyro solver, we can go to the simulation. No, actually in the pyro solver. In the advanced tab, in the collisions, you should uncheck use point velocity for collisions, and I found that use volume velocity for collisions actually works. So I still not sure if you want to use this volume velocity, but it sounds pretty logical to me to use volume velocity for collisions. And here you can see that as our volume is expanding, we are calculating these collisions here. I don't think that we need gravity acceleration or buoyancy actually. For the smoke object, yeah, voxel size is bound to the particle separation. Here everything is all default. And for the pyro solver shape, yeah, again, turbulence, dissipation. Let's set the dissipation to 0.01 just for the speed of this tutorial, because we want to simulate a few frames, I assume. So let's go to the smoke object guides visualization. Let's remove this collision guide and let's go back one level. Let's go into the DOP import fields. We don't actually need the wheel right here. Let's just simulate. Let's here in controls, let's set it to be particle separation. Let's set it to be like 0.5 because yeah, we want a bit more detail. I think in my example, I actually set it to 0.02 or 0.01, but let's simulate a few frames and then I think we will be done with that. And finally, we will be able to set the materials for our wheel, for our smoke, and talk about how we can render it out in Redshift. So here we have a few frames simulated and we have our smoke, our beautiful, beautiful smoke here. Yeah, I would say that we probably will need a bit more detail here, but for the sake of tutorial, I think it will work fine for now. So, of course, save it before we do anything. So, in the material, what we need to do is create materials, of course. RS material. I'm not using that standard material, that new material, by the way. Redshift material and connect this one. Oh, not in the displacement, just into the surface. Boom, like this. Copy that a few times because one of them will be the tire material. Material. Another one will be rim material. And this one will be our BG material because we will have to add sort of a plane for cool reflections. Nice. Now we need a volume, RS volume, and redshift material. Boom. And this goes into the volume. Oh, smoke material. Cool, I think we are very good with this one. Let's go to the wheel. Let's set the tire material to be tire material in our magnet. Tire material. Rim material should be rim material. Then add a grid, just because why not? Rotate it 90 degrees. Push it back slightly. Push it down and push it back, of course. Like that. Yep, sounds good. For the smoke, redshift OBJ. Nope. Render material, smoke material. For the grid, BG material. And of course we can remove the primary ray visibility and refractions visibility, so we can render it with alpha. Okay, for the RS light dome, I will be using the one that I use the most, Brown Photo Studio, saturation set to 0. Probably can rotate it. Nope, not this one. Yeah, I want to rotate it 92 by Z. Yeah, we'll need to fire up the renderer to see actually. But yeah, I think we can select this little plus icon, new pen type, pane, tab type, redshift, render view. And let's fire up the render and see if anything works here. Not bad, not bad. Yeah, I think for the RS light dome, we can uncheck that we want it for the background environment. And yeah, start working with our textures. Let's go into the magnet, and tire material will be our plastic, I think, and it should be black plastic. And it looks good. For the roughness, RS max on noise. I want to use the noise. Diffuse, nope, reflection roughness. Yeah, and I want it to be, of course, for the first thing that you want to do is in the input, source should be set to UV vertex attribute, and the noise type, FBM works good. Stipple Stapple works also good. But also Luca or Hammer was also good. We can probably preview it by plugging the Maxon noise into the diffuse color. Yeah, not bad. I like. Cool. Then for the rim material, aluminum with of course diffuse color makes nothing because the weight is set to 0. Either set it to be 0.5 here, which also doesn't do much. But reflection color, we can set the reflectivity to be something like this. Here you could also probably add Maxon noise to this one in the reflection roughness. Yeah, why not? Why not? But we are all here for the smoke, right? So, thing that worked for me, right? Absorption coefficient should be set to sort of like 5, and scatter coefficient set to 20. Actually, like, oh no, 10. And scatter remap ramp is the thing that makes it look beautiful. So I used this Inferno, and you can see how beautiful it looks. Absorption coefficient, the bigger it will be here, the kind of darker your smoke will be here. I set it at, I think, at 5. And also you can play with the shadow density scale, set it to 5 or set it to 3. And max, you can also play with that because you can see how the colors are changing when you are setting this new max. Of course, you can set it to be 0.2, 0.3. It basically goes on your ramp here, this ramp here. Yeah, absorption coefficient, it just makes it like look full, you know. What else we need to do is here in the wheel, actually no, here everything is good. We can just go to the redshift rope, and for the redshift, switch to advanced, motion blur enabled, and start should be at 0.1 and end should be at 0.95, I would say. And deformation blur, instances blur, and let's check. Yeah, now we have the deformation blur here. Then I would say in the sampling, make sure that you are not using automatic sampling and you are overriding volume with something like 512. And here I used, I think, 16 128 and 0.001 as a threshold. Also make sure that in the smoke, here you can just drop your file cache and cache out 210 frames because our rotations keyframe to 210. So yeah, this is what we have. Pretty neat looking setup. This is it, guys. Let me know if you enjoyed this a bit longer tutorial. Should I continue creating my tutorials like this, or we should stick to how it was before? Anyhow, I really hope you learned a lot of new things today, and of course there will be a new tutorial next week, so I'll see you guys soon. Bye!